Good day, students. Welcome to mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 16 to 20 of the January 2017 Algebra 2 Common Core New York Regents exam. All right, let's take a look at question number 16, which reads, Pedro and Bobby each own an ant farm. Pedro starts with 100 ants and says his farm is growing exponentially at a rate of 15% per month. Bobby starts with 350 ants and says his farm is steadily decreasing by 5 ants per month. Assuming both boys are accurate in describing the population of their ant farms, after how many months would they both have approximately the same number of ants? Alright, so let's go ahead and write down the formulas that basically describe the growth process or the decline process of the number of ants in both farms. Okay, so let's write down the formulas. The first formula we're going to look at is the exponential model. Okay, how would you describe an exponential growth scenario? So we're going to call that an exponential growth model. For an exponential growth model, what you have is y, the final amount, equals the initial amount times 1 plus, okay, plus r raised to the x power. Now, if it were a decay scenario, this plus will be a minus. Formula number 2 is the linear decay model. Okay, linear decay basically means that the amount is reducing, is going down. Because if you look at the second case, the situation with Bobby, the number of ants in his farm are decreasing, so we have a decay scenario there. So in this case, we're going to have y equals our slope m is going to have a negative sign. Okay, so we're going to have y. It's going to be y equals mx plus b, but m is going to be negative. That'll help us with the decay situation. Okay, so let's go ahead and write down the relevant components for both situations, and then we can determine the particular x value where they have exactly the same number of ants. We're going to start taking a look at Pedro's situation. So with Pedro, he started with an initial amount of 100 ants. Okay, so the initial amount for Pedro is 100. He has an exponential growth rate, r, of 15%. Of course, we want to convert this to decimal form, which is 0.15. This is accomplished by moving the decimal points to the left 2 places. Pedro's exponential growth model, p of x, is going to be the initial amount times 1 plus the the growth rate raised to x. If we simplify it, Pedro's growth model, exponential growth model, is 100 times 1.15 raised to the x power. Okay? Now let's take a look at Bobby's case. Bobby's case, we are having a decrease in the number of ants. So for Bobby, we just need the slope m and b, the initial amount. So for Bobby, we have m. The slope is going to be decreasing at 5 ants per month. Okay, 5 ants per month. So it's going to be -5. And the initial amount, he started with 350 ants. So the question might arise: how do we know that Bobby's scenario is linear while Pedro's scenario is exponential? If you take a look at the problem, it says that Pedro's says that his farm is growing exponentially, so that's easy to determine that Pedro's case is exponential. But in the case of Bobby, there is a steady decrease. So it's decreasing by the same amount every single time. That's what a linear decay scenario looks like. All right. Okay. So in Bobby's case, his decay model is going to be b of x equals mx plus b. M is negative 5 for m, x plus d, starting amount of 350. Now the question asks us, when will they have the same number of ants? So the two farms, Pedro and Bobby's, the two farms will have the same number of ants when what? When p of x, the exponential growth model for Pedro, is equal to b of x, the linear growth model for Bobby. Okay, so all we just do is simply set the two equations to each other. 100 times 1.15 raised to the x. Set that equal to Bobby's decay function, negative 5x plus 350. And then we'll basically see which, what's the point of intersection here. So let's go ahead and graph both cases and see what the intersection point is. So go to our y window. Let's enter Pedro's first. 100 times 1.15 raised to the x power. And then for Bobby's linear decay scenario, we have negative 5x plus 350. All right, now we're going to graph it. So we hit graph. So what we're looking for is the intersection of the two graphs, okay? So we see that BZ symbol there, it's gone. So the two graphs have been plotted. We can't see anything, okay? So the graph can't really help us here unless we know the exact window that we want to use. So the question is there another tool in the calculator that can help us to estimate? Because what we're doing is we are approximating. We have 4 options here, so we can look at them and basically approximate. So one good tool we can use is the table. So go to the table, and then we can be able to determine what the correct answer is, okay? So the first one is Pedro's growth situation. So if you take a look at the y's, it's increasing, okay? And then if you take a look at the x's, what's happening? The x's, I'm sorry, if you take a look at the second y, which is Bobby's, you notice that it's decreasing, okay? So we want to look for the specific x value where the difference is the smallest, all right? So let's look at 7 first. We have 266 and 315. Okay, how does that compare with option 8? Option 8 is 305, like 306 and 310. That's just a difference of 4. Okay, what do you think is going to start happening after that? Y1, Pedro's model, is going to keep increasing at a even faster rate. And Bobby's scenario is going to decrease at a steady rate. Never again will they get anywhere close to each other. Okay, so option 3, which is 13, see the difference there? That's a huge difference. And then 36 is even going to be worse. So the closest particular x value where they are closest to each other is when x is equal to 8. Okay, so when x is equal to 8, that's the approximate time when they will have roughly about the same amount of ants in their farms. All right, let's take a look at question 17. It says, what is the solution, if any, of the equation? Okay, so we have a rational equation here. So let's go ahead and get started. We have 2 over x plus 3 minus 3 over 4 minus x equals 2x minus 2 divided by um, x squared minus x minus 12. Okay, so what we're going to do is we need to multiply the entire equation by the LCD. Okay, when we multiply by the LCD, what is going to happen is that we will eliminate the denominators. Okay, so that's the goal. Now, before we do that, you notice that the denominator for the 3 over 4 minus x is not written in standard form. So let's go ahead and fix that. We're going to write this as 2 over x plus 3 minus. Now I'm going to reverse these two. Okay, I'm going to rewrite it as x minus 4. Now, when you switch the order of a difference, you must introduce a negative. Okay, order matters when you're subtracting. Subtraction does not commute, unlike addition and multiplication. When you switch the order of a difference, you have to put a minus on the outside. So keep that in mind. And then we have 2x minus 2 divided by. Now let's see if we can factor this denominator quadratic trinomial right here. So let's factor x squared minus x minus 12. Okay, let's use the x game. AC is negative 12, B is negative 1. Two numbers that multiply to give you 12 and add to give you negative 1 are negative 4 and 3. So since A is equal to 1, we can jump to the factored state. No need to factor by grouping, okay? So there goes the factored form. Put it down here. X minus 4 times x plus 3. So the LCD is basically the polynomial expression that all these three go into evenly. All right? The LCD, let's write it here. The LCD of x plus 3, x minus 4, and x minus 4 times x plus 3. What's the LCD? The LCD is x minus 4 times x plus 3. Okay, just the product of the factors. So we're going to multiply every single term by that LCD. The result is the elimination of the denominator quantities. So multiply this by x minus 4 times x plus 3. This one times x minus 4 times x plus 3. Okay? Now, let's take a look at the first term. The x plus 3 is divide out. You can distribute that 2. You have 2x minus 8. All right, over here, the x minus 4 is divide out. We have minus divided by a minus. That becomes a plus. Distribute the 3. You have 3x plus 9. When this 3 is distributed to the x plus 3. Okay. On the right side, this x minus 4 divides that out. X plus 3 divides that out. And you're left with 2x minus 2. Let's go ahead and combine like terms. We can combine 2x and 3x. That gives us 5x. Minus 8 plus 9 is positive 1. That is equal to 2x minus 2. If we add 2x to both sides and subtract 1, that's going to give us, actually we subtract 2x from both sides, we have 3x. And then we subtract 1 from both sides equals negative 3. Okay, so you subtract 2x and you subtract 1. And then lastly, just divide both sides by 3. Divide by 3, divide by 3. And you get your answer, x equals negative 1, as the final result. Our answer for number 17 is option number 1. Okay, let's take a look at question 18. It says, in 2013, approximately 1.6 million students took the critical reading portion of the SAT exam. The mean score, the modal score, and the standard deviation were calculated to be 496, 430, and 115 respectively. Question: which interval reflects 95% of the critical reading scores? So let's go ahead and write down a formula for the particular population using the normal curve. So the formula is as follows. If you're taking a look at you're looking at 95% of the population, that's represented by the mean plus twice the standard deviation. Okay, so let's write it in verbal form. So it's the mean, well, plus or minus. So you're going to go 2 standard deviations to the right and 2 standard deviations to the left. So the mean plus or minus twice the standard deviation. Now that will capture 95% of the population. Okay, so let's say, let me just sketch something real quick. Let's say we have a normal curve. Okay, the population is normally distributed like this. If we go 2 standard deviations to the right and left from the mean, let's see, this is the mean right here, and then you go 2 standard deviations to the right plus the standard deviation, so you have that, and then there's 2 standard deviations. If you go 2 standard deviations to the left and right, what you're going to capture is 95% of the entire population. Okay, so 2 standard deviations to the right, so there's mu plus 2 standard deviations. And then when you go 2 standard deviations to the left, right here you have mu plus minus 2 standard deviations. Okay. Now this combined population right here represents what? 95%. So that's what we're going to use. Okay. All right. So the mean in this scenario is 490. We're told that the mean score is the first one, 496. I said 490, 496. And then what's next? The standard deviation. Those are the 2 that we need to determine the correct answer. Okay, so the standard deviation is what? What is the standard deviation? It's the last numerical value, which is 115. 115. Okay, so 95% of the scores is going to be given by the mean 496 plus or minus twice the standard deviation of 115. When you double 115, you have 496 plus or minus 230. Answer for number 18 is option number 4. Alright, let's take a look at number 19. It says, which statement regarding the graphs of the functions below is untrue? Okay, so we're looking for the false statement. Alright, so what you can easily do, you can input these functions into the calculator, and then you can go through the different answers that are here. Alright, but we're going to do this by hand. So let's take a look at the first statement. It says f of x and g of x have a maximum y value of 3. Let's start with the f of x function. The f of x function is 3 sine 2x. That's a trig function, a sine function. This function right here tells us that the amplitude, the coefficient of the sine, is 3. So you go plus or minus 3 from the central position. The period is 2 pi over b. 2 pi, the b value is 2 over 2, which is pi. So one complete cycle would be pi radians long. Okay, that's enough information for us to sketch the graph. We're going from negative pi to pi. Okay, so let's draw the graph. This is going to be, let's call that, that's pi over 2, and then that's going to be pi. That's going to be a complete cycle. And then going in the other direction. So if you're graphing the sine curve, you have to remember basically what it looks like. Remember that the sine curve is like an S, okay? And the cosine curve is like a cup. So we're doing the S for the sine curve, so it looks something like this. Let's draw that again. So goes up, and then to there. So if you draw it in your calculators, this is what it's going to look like, all right? What's the maximum value? The amplitude tells us it's going to be 3. So you can see that the y max is 3. So that's good for f. Is that the case with j of x? It's the maximum 3. So let's graph that one too. You can graph it with your calculator, but let me just do it by hand. When you graph with your calculator, it's easy to see what the maximum value is. So g of x is your absolute value function, negative absolute value of 4x minus 2 plus 3. So here we can factor out to see the exact shift horizontally. We can factor out 4. So 4, if you factor out 4 from the first term, you divide by 4. X. If you factor out 4 from 2, you divide by 4, negative 1/2. Plus 3. So this one basically tells us that we're going to shift to the right 1/2, and then we're going to shift up 3, and then we're going to flip down. Those are the transformations. Alrighty? So we're looking for the maximum, so we don't have to graph this function perfectly. It doesn't really matter. We just want to know where the vertex is. So for the vertex, we're going to shift 1/2 units to the right. So let's say this 1, 2, 3, 4. This is 1. We're just going to go 1/2 units to the right, and then 3 units up, 1, 2, 3, and then the graph is opening downwards. Because of this negative here, it's flipped. Okay? So what do you think the maximum value here will be? Maximum value is going to be 3. So y max for the logarithmic function is 3. I'm sorry, for the absolute value function is 3 also. So statement number 1 is true. Okay, statement number 2. For statement 2, it says f of x, h of x, and g of x have one y-intercept. So for option 2, we already have f of x here. Oh, and another thing that we want to note is that the endpoints for my trig function are actually open circles. Pi is not included, okay? All right, so it says it has one y-intercept. So if you look at f of x, does it intersect the y-axis once? Absolutely, at 0. So this is true. For h of x, we have the logarithmic function. You can graph that. Well, it's hard to graph that in your calculator, but you can graph that by hand. If you want to graph this in your calculator, you have to do a conversion of your logarithms because calculators normally do log base 10. Or if you have a more modern calculator, you should be able to graph it. Okay, what you want to remember is that the logarithmic function has a vertical asymptote on the line y equals 0. What does that mean? That basically means that the graph never touches or crosses the y-axis. Okay? So keep that in mind. So that can help us with our graph of the log function. Okay? So if we want to graph the log function, it looks something like this. Bam. With a decreasing growth rate. Okay? So log base log of 1 base 2 is 0, because 1 is 2 to the 0th power. So this coordinate right here is 1 comma 0. So since we have a vertical asymptote here, this function has no y-intercepts. Does that agree with the claim that h of x has one y-intercept? Nope. So this statement is untrue. So that tells us that this is the answer we are looking for. Okay, let's look at number 20. It says when g of x is divided by x plus 4, the remainder is 0. Given g of x equals x to the 4th plus 3x to the 3rd minus 6x squared minus 6x plus 8, which conclusion about g of x is true? So let's go ahead and recollect the theorem known as the factor theorem. So the formula we're going to use here is the factor theorem. Okay? So it just basically tells us that if x minus r is a factor of some polynomial, let's call it p of x, is a factor of p of x, then what? Then, when you input the 0 of the this factor polynomial right here, which is r, into the polynomial function, your answer is going to be 0. Okay? So let's apply this factor theorem to this scenario right here. So what are we going to plug in to g of x? If x plus 4, okay, this quantity, this expression, if it is a factor of this polynomial, then it's related 0. So you must set it to 0 first and solve for x. Okay, so you subtract 4 from both sides and you solve for x. You get x equals negative 4. Now, when you plug in the related 0 into the polynomial function that x plus 4 is a factor of, then you should get 0. Okay, so let's go ahead and apply it. Apply the factor theorem here. If x plus 4 is a factor of g, then what? Then g of the related root of that factor, then g of negative 4, not 4, is equal to 0. So the correct answer is option number 2. Okay, if you want to test it out, all you just have to do is you write down g of x, okay, x to the 4th plus 3x to the 3rd minus 6x squared minus 6x plus 8. Okay, and then you plug in the related roots to x plus 4. So you plug in negative 4. Okay, so you have negative 4 to the 4th plus 3 times negative 4 to the 3rd minus 6 times negative 4 squared minus 6 times negative 4 plus 8. You work it out with your calculator, you will end up with 0. Okay? And that basically shows that option 2 is the correct statement. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming Regents exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this tutorial, please place your comments in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other test prep tools such as this. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day. Goodbye.